want to find the exact values of each of these trig functions. So we are going to follow those 5 steps from the previous video. I'm just going to show you a bunch of examples with those. So first thing we want to do is draw this. We have a 240-degree angle. So here's our initial side. 240 is going to be in the 3rd quadrant. I don't know, maybe around there. That looks good. And now we want to find the reference angle. So we want to find this angle that it's making with the x-axis. So that's going to be 240 minus 180, which is 60 degrees. So this is going to be a 60-degree angle right here. And now we want to finish drawing the triangle around that 60-degree angle. There it is. And now this is a 30, 60, 90. That's one of our special ones. So across from the 30 is 1, hypotenuse is 2, and across from the 60 is root 3. Now, we also need to think about this coordinate. We have gone left 1, so that needs to be negative, and down root 3, so that also needs to be negative. I'm running out of space there. The hypotenuse is always positive, so don't ever worry about that sign. All right, and our last step is to find the cosine of this angle. Cosine is adjacent over hypotenuse, so the adjacent is -1. And hypotenuse is 2. And if you want to check this on your calculator, if you type in cosine of 240, it should tell you -1/2. All right, let's check out another one. Tangent of -45. So here's our initial side. Negative means we're going into the 4th quadrant right there. We want to find this acute angle with the x-axis, which we already know. Oh, that was not, hang on. That was not a pencil. That's why it didn't work. We already know that that's 45 degrees. So we will draw the rest of this triangle. And now we have a 45, 45, 90 triangle. So we're going to fill in the sides. The sides of a 45, 45, 90 are 1, 1, and root 2. And again, think about this as a point. We are right 1 and down 1, so that's going to be a negative. And let's see, we want to do tangent. So the tangent of that is opposite over adjacent, so -1 over 1, which is just -1. Again, you can check this in your calculator, type in tangent -45, and it's going to tell you -1. All right, the next one is in radians, which is exciting. So pi over 6, we want to draw that. So here's our initial side and our terminal side, because remember, all the way up here, that's half a pi. We only have a 1/6 of a pi, so right in there. And if you want, if you don't feel comfortable doing this in radians, you can go ahead and convert that if you'd like. Let's see, pi over 6 times 180 over pi. Pi's will cancel. This is the same thing as a 30-degree angle. So we're finding the sine of 30 degrees. This is 30 degrees. Since we're in the 1st quadrant, we don't need a reference angle. We're fine just the way we are. So we'll finish drawing this triangle. This is a 30, 60, 90 triangle. The 60-degree angle is up here. I'm not going to write it because my triangle's too small. So across from the 30 is 1. Hypotenuse is 2. And then across from the 60-degree angle is root 3. And since we're in the 1st quadrant, that should be a positive and a positive. So we don't have to worry about any negative signs. And then we want to do SOHCAHTOA. The sine of this triangle is opposite over hypotenuse, or 1/2. You can also do this in your calculator. You can do radians in your calculator. You have to put it in radian mode, which if you're in Desmos, I think it's just a button that you click. I can't remember exactly where it is. On your calculator, if you have your calculator, there's a button towards the top that says DRG, degrees, radians, gradians. You push that, and then it pops up on your screen, and you just go over to radians and hit that one. So if you go into radians, and make sure then your calculator will now say rad at the bottom instead of DEG, you can do sine and then do pi over 6, and it'll tell you 1/2. Okay, but make sure you switch back to degree mode for when you want to be in degree mode. All right, let's check out the next one, tangent of 405 degrees. So the first thing we want to do is draw this. Let's see. Initial sides here. Terminal side, we're going all the way around and then some, it looks like. And if it would be easier, we could think about a coterminal angle because 405 is not in our normal circle. So you can go ahead and do that. You can take 405 and subtract 360. So a coterminal angle is 45 degrees, not negative 45. That's just a regular 45. I don't know what's happening there. That's an equal sign. I don't know what's going on. Okay. So this is just a 45-degree angle. There it is. And we don't need to worry about finding the reference angle because we know that that's 45 degrees. So we'll finish drawing that triangle. This is a 45, 45, 90 triangle. So the sides are 1, 1, root 2. Since we're in the first quadrant, that's right 1 and up 1. Those are both positive numbers. So all we need to do now is the tangent of that angle. Tangent is opposite over adjacent. So 1 divided by 1, which is just 1. If you put this into your calculator, tangent of 405, it should tell you 1. Make sure you're back in degree mode. All right. Let's tackle this next one. We want to do the sine of pi over 2. So the initial side is here, and pi over 2 is straight up. That's a weird one. So the problem with this one is this is a 90-degree angle, and it's really hard to draw a triangle with the x-axis. So instead of drawing the triangle, I want us to think back to, remember that unit circle that was on the front side of this page? How well can I draw a circle? There. Okay, remember that unit circle? This had the points 0, 1. And we said that x was the cosine of the angle and that y was the sine of the angle. So that's all we need to do. If we want to know what the sine of pi over 2 is, it's the y coordinate. It's 1. If you had been asked what's the cosine, if you had been asked what's the cosine of pi over 2, you would think about this point on the unit circle and you would say, oh, it's just the x coordinate there, which is 0. If you have trouble remembering these, x and y, they're alphabetical, just like cosine and sine are also alphabetical. That's how you remember which is which. All right, let's try another one that's really similar to that. So we want to find the cosine of negative pi. So here's our initial side, our terminal side. We're going this direction over here. Now again, it's going to be super hard to draw a triangle and figure out a reference angle. I have no idea. So instead of doing that, we're going to think about our unit circle. And we're going to think about this point. This point is negative 1, 0. And if we want to know the cosine over there, the cosine is the x-coordinate. So the answer is negative 1. If someone had asked you what's the sine of negative pi, well, that would have been the y-coordinate, which would be 0. Okay, so if you are asked to find the sine, cosine of a quadrant angle, so 90 degrees, 180 degrees, 270 degrees, use the coordinates on the unit circle to find those. It's a lot easier that way. We'll finish up with a few more problems in the last video.